Hello, thank you for watching this video. So in this video, we'll be doing part 2, or maybe this is the continuation of our proportionality. So on the first video, we laid foundation for proportionality theorem, and we proved the proportionality theorem. So on this video, we're going to do the converse of the proportionality theorem and some few outcomes, and then we're going to do a lot of examples so that at least you know how to apply the proportionality theorem. So here's the reminder. So we said when we were doing the proportionality theorems that if you have a line parallel to one side of a triangle, so that line will divide the two other sides proportionally, right? So you have triangle ABC, right? And then you have DE. This DE is parallel to BC. So what we said on the previous video is that this side will divide, this line DE, this line segment DE will divide these two sides proportionally. Does that mean equally? Not necessarily, right? But it means that DE will divide those two sides, which is AB and EC and AC at equal proportions. What does that mean? How does that look like? Which means if we say, as long as you take the ratios of the same parts, you are okay. That's what that means. Which means if you say your AD consists the top side, the top part, above DE and then over DB, it should be equal to, which means you can see your AD was the top part, so it should be the top part on the other side as well, which is your AE over EC, right? Or you can say maybe the entire side AB over the lower part DB, it should be equal to the entire side, that side, which is AC, over lower part EC, right? Or maybe you can say what? You can do the similar stuff and say your entire side AB, which is the entire side AB over the top part AD, is equal to the entire side AC over the top part, which is AE, as long as you take the ratios of the same parts. So at the end of the first video, I was doing a lot of these ratios. So if you don't know or remember them, you can go back. But these are the ratios that I was proving or showing at the end of the previous video, or part 1 of the proportionality. So now, what are we going to do in this video? So in this video, we're going to do the converse of the proportionality theorem, which is now the reverse of the proportionality theorem. So in this case, on the original, which is the proportionality theorem, we say that if you have a triangle and that triangle is divided by a line segment that is parallel to one of the sides, so the two sides that it is joining on, it will divide them proportionally. So now we're going to go for the converse now. That's what we're going to go for. So what do we say on the converse? If we have a triangle, let's say ABC maybe, and your ABC is divided by a line segment proportionally, what does that mean? That should tell us that we are trying to say that DE should be parallel to BC. So if a triangle ABC and the line segment DE, not necessarily parallel, you're not told that it's parallel, but if that line DE divides the two sides proportionally, then we are trying to prove that DE would be parallel to the third side. So I'm just going to write it here, but I'll write it as if and then. So let's say we have a triangle, this triangle here. Let's say it's X, Y, Z, right? And then let's say this is PQ. PQ. What I'm saying is that if your XP over PY, which is XP over PY, equals what? Equal to XQ over QZ. Then the claim is that your PQ is parallel to YZ. I'm not sure if that makes sense. So what I'm trying to say to you, if you have a triangle XYZ and that XYZ is divided by the line PQ, such that your PQ divides those two sides proportionally at equal ratios. When I say equal ratios, not necessarily these ratios, all these ratios they hold, including the ones that I proved at the end of the previous video. Right? So what I'm trying to say is that we're trying to prove that your PQ should be parallel to this. So if you have a line segment that divides two sides of a triangle proportionally, that line segment should be parallel to the third side. That's what we're going to prove. So it's the converse of the proportionality theorem. You are moving in reverse. I'm not sure if that makes sense. So what I'm going to do, I'm going to write the statement, I'm going to clean the board, write the statement of the converse, and then we'll try to prove the converse of the proportionality theorem. So that's what I'm going to do now. So let's clean the board and write the statement, and then get on with the proofs and the outcomes of that. Okay, so now let's get started with the converse of the proportionality theorem. So we're saying, here's the converse. We're saying a line that divides two sides of a triangle proportionally is parallel to the third side. Proportional, what does it mean? It means equal ratios, right?
Yes.
And you know all those equal ratios that we talked about. So here's what we have here. So we have a triangle ABC, right? And DE is the line that divides these two sides of our triangle proportionally, which means the ratio of AD over AB over DB equals to that of AE over EC. So what we're trying to prove is that this line, that proportionally part, which is if this line DE divides those two sides at equal ratios, then we're trying to prove that DE should be parallel to BC. Are you happy with that?
Yes.
So we can get started. But before we start, what do we want to prove? Right? To prove. This is what we want to prove. We want to prove that our DE is parallel to BC. Right?
Yes.
And what are we given? From this statement, we're given that our AD over DB equals what? We call it AE over EC. So now we can get started with the construction. So let's construct some stuff. Construction. So this construction will be similar to what we did in the previous question. So I'm going to say, let's mark X and Y on AD and AE respectively, right?
Yes.
So going to mark X on AD, so here's AD, X, and Y on AE, such that your XE, which is XE, is perpendicular to what? Perpendicular to AB. Are you happy with that?
Yes.
And DY is perpendicular to AC. So we're going to mark this line here. So we mark the point E such that this is 90 degrees. Mark that point Y so that this here is 90 degrees. So if you look at XE and YE and DY, you can see that these are perpendicular heights of this triangle. So those are altitudes of that triangle. Right?
Yes.
No problem. Then what do we do? After working these, we're going to, done that. What else are we going to do? We're just going to join this and that. So we're going to join BE. Going to say, okay, let's join BE and DC. So we join this. Join this and join that. Once we have done this, we're going to calculate areas. Our first area should include AD. The second one should include DB. Third one should include that. The third one should. So all of these alphabet, these sides that you see here, they should be based off some triangles. So you can see that there's AD. Go look at the triangle that contains AD, the side AD. AD is contained in triangle ADE. So go and calculate that area of the triangle so that your AD is the base of the triangle. So we're going to say, okay, now we're getting on with the proof. Area of triangle ADE equal to half base ADE. Since we have AD, our base should contain AD. Right? We want AD to be our base of that triangle. So if we have AD, so we're going to say half base, which is AD times perpendicular height.
Yes.
What is our perpendicular height?
It's XE.
It's XE. So we're done with the area that will contain this part. Go to the area of the second part. So we're going to say area. Where's the second part? Second part is dB. So where's dB? dB is this side. Where's the triangle that contains dB? Is dBE. Can you say dBE?
Yes.
Department of Basic Education.
Yes.
So we're going to say area of triangle dBE equal to half base. What is your base? Your base is your dB. Where is it?
Yes.
You can say over there. dB times perpendicular height. If you look at this, dBE. dBE is an obtuse triangle.
Yes.
So its height is there. It's XE. So times perpendicular height XE. We're done with this part. Next, go to calculate. Actually, after doing this, take the ratio of these areas.
Yes.
So this area of this over area of that. So we're going to say the area of triangle ADE, because we want to have a similar ratio as that one, over the area of triangle DBE. What you will have is going to be half AD times XE over half DB times XE. Are you happy with this?
Yes.
So this and that will go away, this and this will go away. You're left with AD over DB. Is it clear?
Yes, it's clear.
After doing this, now you come to the side. Come and calculate areas that will involve these sides as bases. So, where is AE? AE is here. It's the side of triangle ADE. Which means you're calculating the area of triangle ADE again, but using AE as your base. Are you happy?
Yes.
So we're going to say, okay, area of triangle ADE equal to half base. Our base this time is what? AE times perpendicular height, which is dy.
Yes.
Are you happy?
Yes.
Now, we're done with the top part. Go to the bottom part. EC. So here's EC. EC is on DEC, on December there, on triangle DEC. So, go and calculate the area of triangle DEC. It's called half base. Your base is what? Is your EC
Yes.
times the perpendicular height. DEC, you can see that it's an obtuse triangle, right?
Yes.
There is this perpendicular height dy over there.
Yes.
dy. So after this, you take the ratio so that you can have something similar to this.
Yes.
So you say the area of triangle ADE over area of triangle DEC equal to half base. What is your base? Oh, actually, just copy those. It's going to be half AE times dy over half EC times dy. So you can see this and this will cancel, this and that will cancel. What we're left with is AE over AC. What are we trying to do? We're trying to prove that your DE is parallel to BC.
Yes.
That's what we want to prove, right?
Yes.
But what we have at this point is that this ratio of these areas is equal to this. And this ratio of this area is equal to that. Remember, we're given that this is equal to this. That was given information.
Yes.
So this is equal to this, which means your AD over DB equals what?
AD
AE over
over AC.
EC. This was given information,
Yes.
right?
Yes.
But AD over DB is equal to that.
Yes.
And AE over EC is equal to this.
Yes.
So which means in the place of this, I can substitute that.
Yes.
So which means I can say the area of triangle ADE over area of triangle
DBE.
DBE. So what up? This is equal to this.
Yes.
There is it.
Yes.
So I just placed this, I just substituted this in the place of this
Yes.
over there. In a similar way, this is equal to this, which is equal to that.
Yes.
So this is equal to area of triangle ADE over the area of triangle DEC.
DEC. Yes.
So you can see that the top is equal to the top,
Yes.
right?
Yes.
So if these ratios are equal, which is the area of this over the area of this is equal to the area of this over the area of that. These ratios are equal. But you know this triangle and this triangle are the same.
Yes.
So the top area is equal to the top area.
Yes.
So the bottom area is also forced to be equal to that. I'm not sure if you understand what I'm trying to say.
Yes.
If you're saying area of ADE over the area of DBE equals the area of ADBE over the area of this. So what that means is that the top area is equal to the top area. So even the bottom one should be equal to the bottom.
Yes.
Or do you want me to solve it?
No.
Because if you want, you can just divide by this area both sides.
Yes.
So you are left with 1 over area of triangle DBE is equal to 1 over area of triangle DEC. Then you can cross multiply here. Well, this times that to be the area of triangle DEC equal to area of triangle DBE. I'm not sure if that does make sense.
Yes.
So if you're saying this is the same as that, so even the bottom should be equal. So now what we've just covered is that the area of DEC is equal to the area of DBE. Where are these triangles? DEC. DEC is this triangle over here. You can see the orange triangle.
Yes.
Trying to make it orange. That is DEC. And then DBE. It is the green triangle. I'll make it green. Here's the green triangle. Can you see?
Yes.
The green triangle. So we're saying the area of the green triangle DBE is the same as that of the orange triangle DEC. Are you following me?
Yes.
So what I'm saying now, if you're saying the area of these two triangles are the same, look, you know that if you want to find the area of a triangle, it's half base times perpendicular height, right?
Yes.
So look, the base is the same on both of them, is DE, right? Because they share the same base, DE. Then the perpendicular height of the green triangle is over here. So if maybe this way to continue in that direction, for the green triangle, the perpendicular height should be this one over here, right?
Yes.
And for the orange triangle, the perpendicular height should be this one over here. Because these are obtuse triangles.
Yes.
So if you're looking at DEB and DEC, right?
Yes.
So they have the same base, right?
Yes.
So the perpendicular height for the orange triangle is this one, and the perpendicular height for, let's say, it's H1, and the perpendicular height for the green triangle here is H2. Are you following?
Yes.
So if we say the area of a triangle is half base times perpendicular height, and they have the same base, and we say their area is the same, which means the perpendicular heights are going to be the same as well.
Can you repeat again?
I'm saying here, these two triangles, the green one and the orange one, they have the same base DE,
Yes.
right?
Yes.
We know that the area of the triangle is half base times the perpendicular height.
Yes.
So we know that the areas are the same. They have the same base, right?
Yes.
Which means now, in order for them to have the same area, even the perpendicular height needs to be equal.
Okay.
And if these perpendicular heights are equal, which means these two lines are parallel, and it will be done. Because if you have two lines and the distance between those two lines remain unchanged, as we are going to get as we need in order to have equal areas, then in that case that means these two lines are parallel, which is DE is parallel to BC. Let me repeat one more time. We say the area of this triangle DEC which is the green triangle, is the same as that of DBE. Or actually, DEC, yes, is green, and DEC is orange, and DBE is green, right?
Yes.
We're saying the area of these triangles are equal. And we know that the area of a triangle is half base times the perpendicular height. So we know that the base of those triangles, they both have the same base DE.
Yes.
In order to look, here's the area of a triangle, or to half base times the perpendicular height, right?
Yes.
So now they have the same base DE. So if these areas are equal, which means they also need to have the same height, and you'll get the same height only if these are parallel. But because the area is the same, which is those heights are the same, which is the lines are parallel. So in that case, we can say from here, what are we going to say? We're going to say, okay, our DE is parallel to BC. Why? Because we have the triangles have the same area, right? We're going to say our triangles have the same area and the same base, which is what? Which is DE, right?
Yes.
So in that case, the height also have the same. The height, therefore, will also be the same, which means now those two lines are parallel. So the triangles have the same base. If this triangles have the same area and the same base, so the two lines have to be parallel because the perpendicular heights also have to be the same. Because in order, if you're saying half base times perpendicular height, and the base is the same, and you want your areas to be the same, your perpendicular heights needs to be the same as well. This is how you do the converse of the proportionality theorem. So, of course, as you know, the other diagrams that are similar to this one, the ones that we drew,
Yes.
they also hold as well, which is this one. So A, B, C, right?
Yes.
Your D and E over here. Are you following?
Yes.
So it applies to this triangle, and it will also apply in this equation as well. This is your A, B, C, right?
Yes.
It's your D and E. The converse will also apply here, applies there, and applies in the exact same way. You can do the same proof with the same construction on these diagrams, which is all the ratios that you know hold on this one. They hold on all of them. And I'm done with this part. Any questions for me?
No questions.
Is it clear?
Yes.
So I'm just going to mention a few outcomes, and then I'm going to do examples after that, and we'll be done.
No problem.
Okay, so now we're going to discuss a bit some results out of proportionality theorem, right?
Yes.
So one outcome, it says that if you have 3 or more parallel lines, right,
Yes.
that intersect 2 transversal, then they will divide those 2 transversal proportionally. Let's say you have 3 parallel lines like this. Can you see it?
Yes.
Here's the second, and here's the third. So let's say all these lines are parallel, and they intersect for some reason, some transversals, this transversal and that one over there. Can you see?
Yes.
So if these 3 lines are parallel and they intersect these transversal, they will divide them proportionally. So which means if you say this is say A, maybe B, C, maybe D, maybe E, and F. So these parallel lines will divide these transversal at equal ratios. What does that mean? In a similar way as it does on a triangle, which means your AB over your BC should equal what? Your DE over your EF. It holds in the same way as it does in a triangle. So you can say your AB over your AC equal to DE over EF. All those ratios in a similar manner, they will hold here as well. This is one of the outcomes. So it does not, so what you prove in the triangle also applies in this case here. So if you have 3 or more parallel lines that intersect 2 transversal, they will divide those transversal proportionally, or they will intersect them in equal ratios, or they will divide them in equal ratios. In a similar way, if you have 2 transversal that are intersected by 3 or more lines proportionally, then those lines should be parallel. Do you understand?
Yes.
So do you want me to draw it as well?
Yes.
So what I'm trying to say is that, let's say you have these lines here. I'm not saying these lines are parallel, right?
Yes.
But I'm telling you that you have A here, B here, C here, maybe D, E, and F. So here I told you that if these are parallel, they will divide this proportionally. So if I'm telling you that these 3 lines divide those 2 transversal proportionally, then these lines are parallel. So if it is given that your AB over your BC equal to your DE over your EF, then these lines are parallel. So you induce the parallelness from that from that division of equal ratios. I'm not sure if that makes sense. So in this case, you can just say, okay, I know because these 3 lines divide these 2 transversal proportionally, then all these should be parallel. Smaller, sort of what you saw on the proportionality theorem. Then from here, I'm going to clean the board and you do some examples, and then we're done. Do you have any questions?
No.
Yeah, so I'm going to clean this, then you do examples and we're done with this thing. Okay, so now we're doing the examples, right? So as you can see here, we're given triangle ABC, right, with DE parallel to BC. So we are told that your DE is parallel to BC. They went on to say, find the value of x, right?
Yes.
They want us to find the value of what?
Of X.
Of x. So because we have triangle ABC, and you can see that this side is parallel to that one, we know that by proportionality theorem that your DE will divide AB and AC proportionally,
Yes.
which is at equal ratios. So what you can say okay, to do this, you must specify which triangles you're working on.
Yes.
Well, so okay, we're looking at 2 triangles, right? In triangle ADE, do you see triangle ADE? ADE.
Yes.
And which triangle? And triangle, the bigger triangle ABC. ABC. I would say, if you're doing this, try to present the same order. Starting with A, you came to B, D, and E. So if you're defining the big one, you want to be consistent. So this will help with the similarity. It's not necessary here, but it will help with the similarity. So it's A, D, E, and triangle A, B, C. So just follow the same order. So if you look at these 2 triangles, you can say your AD over your DB, which is your AD over your DB, is equal to what? Is equal to your AE over your EC. Do you see this?
Yes.
Say this lower part over the top part is equal to that lower part over the top part. As long as you take the ratios of the same parts, your proportionality theorem will work. Why did you say that these are equal? You say, okay, I'm saying these are equal because I'm applying the proportionality theorem, right? Why does the proportionality theorem work? It works because our DE is parallel to BC. This is how to reason about the proportionality theorem. You see, I'm applying the proportionality theorem because of those parallel lines that you can see. Are you following me?
Yes.
So in that case, what is your AD? Your AD is 10.5 over 34.5 is equal to your AE. What is your AE? It's 7 over x plus 1. And then you solve for x. Then you cross multiply. This time that it will be 10.5 times x plus 1 is equal to 7 times 34.5. Are you following?
Yes.
Where's the calculator? Over there. You can have this one. Okay, we'll use this one. So in that case, here we'll have 10.5x. Okay. This times this to be 10.5x
Yes.
plus 10.5 is equal to, what is 7 times
It's 7 times
34.5? It's 241.5. Right?
Yes.
It's the same. She's not working.
It's okay.
Okay. So this times this just multiply 7 times 34.5.
34.5.
Is it 241.5?
Yes.
Okay. That case, just solve for x, take this to the other side. So it will be 241.5 minus 10.5. You got 231. So
Yes.
I get 10.5 x is equal to 231 divided by 10.5 divided by 10.5. Okay, that x value is equal to 231 divided by 10.5. You get 22.
Same as.
22. So which means the x value is 22. Right? But if you want to find the side EC, if you want to find the length of EC, it's going to be x plus 1. So which means your side EC, the length of the side, is going to be x plus 1, which is equal to 22 plus 1, which is 23. I'm not sure if that does make sense.
No, it
Does make sense.
Yes.
So I'm going to write another example here, maybe example number 2. Okay, so now we're doing the second example. So on the second example, they're saying you are given triangle PQR with x being the midpoint of PQ and xy parallel to QR. So we are given triangle PQR. Can you see triangle PQR?
Yes.
And you're told that x is the midpoint of this line. So it doesn't look very midpointy on the diagram.
Okay.
But this side is equal to this one. And they went on to say that x is your midpoint and your xy is parallel to QR.
Okay.
Are you following that?
Yes.
So on the first question, they want us to write px over pq. Can you say that?
Yes.
Px over pq. So we can see px is just this part,
Yes.
but pq, which is the entire side, is px plus xq. So
Yes. Yes.
px is just equal to px, because px is px,
Yes.
right?
Yes.
Look at pq now, the one that we want. Pq is px and xq.
Yes.
So you say px plus
XQ.
xq. Are you following?
Yes.
But we're given that px and xq are the same. They're equal. Because if x is the midpoint, then these two should be equal.
Yes.
This side and this length, px and xq.
Yes.
So in that case, you have that your px is equal to xq. Why? This is given because x is the midpoint.
Yes.
So which means you can express your pq as just px plus px. Because this is that. So it's double the px's. So Therefore, you can say, okay, now our PQ is equal to 2 times PXs.
Yeah. Yes.
So if you want the ratio of PX to PQ, it's going to be PX over PQ is equal to PX is PX, right?
Yeah.
So you can say PX over PQ, which is 2 times PQ. So oh no, it should be 2 times PX.
PX, yes.
2 times
PX.
PX. Because this is equal to PX and that is equal to PX. So this and that go away. So left with 1 over 2. That's it. Does it make sense?
Yes.
Doesn't matter, you could have said that it's equal to 2 times XQ.
Okay.
And then you could have said that 2 times XQ, because the same as that. As long as you also use the XQ there as well, you can do the same cancellation. Are you happy?
Yes.
Then, this was A, of course. At B, what do they want at B? At B, they want PY over PR. So they want PY over PR. But if you're looking at this, isn't that this is the midpoint of that? So what you can see that X is the midpoint of PQ. And this side is parallel to this.
Yes.
This is the converse of the midpoint theorem. Did you think?
Hmm.
This is the converse of the midpoint theorem.
Yes.
What does it tell you about these two sides?
They also.
So which is this side and that side should also be equal.
Yes.
Which is this side and this side should be equal as well. That's the converse of the midpoint theorem. Because look, if you're saying this is equal to this and this is parallel to that, then the converse of the midpoint theorem tells you that this is equal to that. So in that case, you want the top part of the entire part. It's going to be the same as that over the entire part. It's going to be the same ratio. So if it was 1 over 2, it's going to be 1:2. Does it make sense?
Yes.
Because the same thing. Because it's this over the entire side. Should be equal to this over the entire side. That's your midpoint theorem. Are you following?
Yes.
So, and if you look, your proportionality theorem will also work as well.
Yes.
So in that case, we can just say that, look, our PY is to PR should be equal to 1, should be equal to 1:2. Because this is half of this, or this is double that. Does it?
Okay, why?
Sorry?
Okay.
Because it's going to be, so PY is half of this,
Yes.
or this is double that.
Yes.
So I don't think we need to go do the same calculation.
I see.
So they're saying, what can you conclude about the midpoint theorem? So like I said, look, you said this side over the entire side is equal to this over that. So if you're looking at midpoint theorem, it's more like you're looking at the proportionality theorem as well. But only the special kind of the proportionality theorem where these two sides, where the divider, the line segment that divides is at the midpoint, joining the midpoints. So what you can say essentially is that your midpoint theorem is a special case of the proportionality theorem, which means it's a proportionality theorem but set to fit certain conditions, which means you should join from the midpoint and these two should be parallel. Or joining the midpoints, or these two should be parallel. So the proportionality theorem is more like a general theorem, and the midpoint is just very specific about the midpoints, as the name suggests. So the midpoint theorem is a special case for the proportionality theorem. That's all we can get from this. Do you want more exercises?
Yes.
I have more. This is exercise number 2. I'm going to clean the board. We're going to do other exercises as well. So now we're doing example number 3, right? So they're saying you're given triangle ABC with PQ parallel to BC. So you're given triangle ABC and your PQ is parallel to BC, which is your PQ divides these two sides proportionally.
Yes.
Right? So they were saying rewrite and complete. So they want us to rewrite these and complete them. So what does this 6 to do? This 6 to enforce those ratios that we spoke about. So the goal of this exercise is for you to be able to identify those ratios that we spoke about. So now I'll say, okay, A here. A, what do we have? We have AP over AB is equal to, let's go and look at AP. AP is the top over the entire side.
Yes.
What is it going to be equal to?
Okay, it's gonna be equal to
AQ
over AC.
over AC. So you said the top part AP, right?
Yes.
Over AB, that's what you were given.
Yes.
So it's going to be equal to the other top part over the entire side AC.
Yes.
Why? So I'm going to say, okay, we're applying the proportionality theorem. Why are we applying? Because our PQ is parallel to what?
BC.
It's called parallel to BC. So this 6 to enforce those ratios. So there's QC over AQ. There's QC, this is B. There's QC over AQ. QC, which is QC over AQ. What is it equal to? So it's the bottom part over the entire thing.
Yes.
Which is equal to what?
BP.
Order.
Okay.
QC.
Okay.
So it's called PB.
PB.
I'm not saying you are wrong. Over.
Okay, it's PB, right? Over BA.
Over AB. So you said QC over AQ, which is the bottom part of the entire side, should be called to that bottom part PB over AB. So the reason is because we're applying the proportionality theorem. Right?
Yes.
Because what? Because your PQ is parallel to BC. We've completed that. So we've done this, done that. Go to that.
That's AP.
AP. So we're doing what? C.
Yes.
So what do we do with C?
It's AP. Over question mark as equal to AP over question mark.
So what do you like this of question marks? So in a case like this, you want to have your things close together like that.
Okay.
So let's cross multiply. Instead, let's just say, you know what? A what? AP. Let's say it's over X.
Okay.
Is equal to AB over Y.
Okay.
And then we cross multiply. So this will come here and that will go to the top.
Yes.
So you have AP over AB is equal to X over Y.
AP.
X over Y.
AP over AB.
Over AB. It's called X over Y.
Okay.
Right? So now, what is your AP? AP is the top part over what? Over AB, which is over the entire side. So it's going to be AQ
Over AC.
over AC. It's going to be AQ over AC. Did you not have something like this?
So?
Did you not have something like this? AP. I think it's this one. Is it not this one? Is it not this? Isn't it this one?
AP. Yes.
Yeah.
Over A.
Because it's AP, which is the top part over the entire side.
Yeah,
it's
it's
equal to
exactly like that.
AQ over this.
Yes.
So this is our X and this is our Y.
Yes.
So what we do is say, okay, the final answer will be AP over our X, which is AQ, is equal to AB over our Y, which is AC.
Yeah.
Let's check if it does make sense. AP over AQ, which is over this side.
Yes.
So it should be called AB, which is that side,
Yeah.
over AC over the other side. So as long as you take the ratio of the same parts, it's okay.
Okay.
So we're done with this one. That one, D. So A D. What do you think we should do at D?
Okay, we have question mark.
Okay, we can put X there.
Okay.
Let's say X over PB equals what?
AC
AC
over Y.
over Y. Then we can cross multiply here.
Yes.
So we're going to be PB.
Yes.
Right?
Yes.
PB times AC, right?
Yes.
Is equal to XY. Right?
Yes.
So PB times AC. Where is PB? PB is this part here.
PB over, okay, times AC.
So this PB, so PB is just this part, right?
Yes.
Times AC. AC is that entire side there.
Yes.
So it's going to be this one and that entire side.
Yes.
Does it make sense?
Yes.
So it's going to be what? QC times the other side, which is AB. Not sure if it does make sense.
I think I'm lost now.
We said PB times AC. So we said this lower part times the other side.
Okay.
So it's going to be this lower side times the other side AB.
Oh, okay.
So in this case, now let's try to bring it back now. Yeah?
Yes.
So it's going to be X over PB, right?
Yes.
So we said it's going to be X over PB. But we don't know which one is X, which one is what.
Problem.
Yeah. So that's what we should try to organize. So we're going to do something over PB is equal to AC over what something. But look at PB. Look at PB over here. PB is that entire, is this lower part.
Yes.
Right?
Yes.
PB is that?
The lower part.
Is the lower part. And AC is that?
AC.
AC is the long side.
Yes.
So how about we say now it's going to be the top part over the lower part, which is it's going to be AB over PB, which is called AC over QC.
Over QC. I agree.
So why? Because I applied the proportionality theorem. Because your PQ is parallel to BC. Does it make sense?
Yes.
So AB, which is AB over PB over lower part is equal to AC, AC over QC. That's it. We're done with exercise 3. I do have another exercise, which is exercise 4. Do have exercise 4, unless you want to take it from here. Do I have a lot of exercises, or do you want to do them?
Yeah, I will do them. Let's just do one more.
One more.
Yes.
Let me look for something interesting. Okay, so now we're doing the last example, example 4. So in example 4, we're given that PV is parallel to QU and parallel to SC, right?
Yes.
And also told that SR is equal to 1/3 of SV. As you can see here, there's some PV is parallel to QU and parallel to ST. So PV parallel to QU parallel to ST. And they're telling you that SR is equal to 1/3 of SV. Are you following?
Yes.
So they want to calculate the values of X, Y, and Z. No problem. So we can see the parallel lines, no problem. So what does this thing mean? So the easy way to work with this is to isolate the alphabets together and leave the numbers together. So which means divide by SV so that SV is on this side. So you have SR is equal to 1/3 SV. So you divide by SV, divide by SV. So this and that go away. So your SR over SV is equal to 1/3. So this thing that I will do. So, because you're familiar with this.
Yes.
So now the question becomes, does this mean SR is equal to A1
No.
and S is equal to 3?
No.
Not in general, right?
Yes.
Because we said when we were doing proportionality or proportions, what you see here, the ratio that you see here, is a simplified version. So you can think of it maybe, it was 1A over 3A. So the A's have cancelled out whatever the common factors were. Whatever the factors were. So what you see here is a simplified version of it. It's just 1 over 3.
Okay.
So now if you want to put this on, now we can say SR is equal to 1A. Where is SR? SR is this length over here. Can you see SR?
Yes.
From here, maybe 1A. Maybe that was this length. Are you following me?
Yes.
So that was the length S1A. And SV, it was what? Is 3A. It was 3A. So if this is 1A over here, so do you agree with me that what you see over here, it should be, so the entire thing is 3A. Because look, SR is just this part from here to here.
Yes.
And SV is from this corner to that corner.
Yes.
So which means from here to here it should be 2A. Do you see that?
Yes.
Because if you want to get 3A, all of it, so this one over here from here to there should be 2A. I'm not sure if that does make sense.
Yes, it does make sense.
Does it?
Yes.
Okay. Now, we're done with this. So you can say this is the side length 1A, and that is whatever that it is there. So now, what do? We want X, so you can see that X is here, is this one over here. So RSQ and RSV. We can apply the proportionality theorem there. In triangle RQU and RPV. Because this is parallel to that. So, and we have a triangle, so it's a proportionality theorem. So it's okay. Let's look at the triangle. In triangle RQU and triangle what? RPV.
RQU. Why is
RQU is this small triangle. RQU and that triangle RPV. So your RPV is divided by QU essentially. Do you see that?
Yes.
So you have a proportionality theorem there. And triangle RPV. So in that case, what we're going to say 1x, right?
Yeah.
It's okay. RQ maybe, or QR over whatever that is. PQ is equal to what? It's equal to RU or UR over VU. Do you agree?
Yes.
This is the proportionality theorem. Why are we applying the proportionality theorem? It's because QU is parallel to PV. So we said QR is QR over PQ is equal to UR over VU. So we want this. So in that case, we'll say, okay, QR is 18 over 6 is equal to X over 5. Right?
Yes.
So cross multiply. So it's going to be, what is 6x is equal to 18 times 5. What is 18 times 5? 18 times 5. My calculator is saying it's 90. So this is 90. Yeah?
That's 90.
Divided by 6, divided by 6. What is your x value? It's 15. So this is 15, which is the x value is equal to 15. So which is this value over here is equal to 15 units. So let's put it in. So we know this value over here is equal to 15 units. There we are. Are you following?
Yes.
Okay. So what do we do next? One y maybe. So there are ways, there are multiple ways you can approach y. One way is you can say, okay, what is this length? RU, RV, or VR?
V.
VR. The length VR is equal to? The length VR
It's going to be 20.
is 20 units. So you can say, okay, 20 units is equal to 2A. and solve for A.
Okay.
Once you find that A, put it here, then you can find your Y.
Okay.
Do you see it like that?
Yes.
You can say, okay, this 20 units is equal to 2, and find the value of A. That value of A, you can put it here, then you get your Y.
Okay.
Or, we apply what we have. We said, we want SR. SR is equal to 1 over 3 times SV. You have SV to be, you have SV, that entire length over there. Right? Doesn't seem like it's going to help us much. SR, what is SR? SR is what we want. Right?
Yes.
It's going to be equal to 1 over 3 times SV. SV is the entire length of this thing here. But we can work something out. Because we know that SR is Y, right?
Yes.
Okay, let me write it down. Well, let's use this. So, we're trying to find Y now. Trying to find Y, which is this part. So we're going to say what SR is equal to 1 over 3 of times SV. Ne?
Yes.
And we also wrote it down here that SR over SV is equal to 1 over 3, right?
Yes.
What is SR? SR is Y. Do you agree?
Yes.
SR is Y, is it?
Yes.
Over SV. SV is the entire thing. So it's 20 plus Y.
20 plus, oh yes.
Because this is 20
Yes.
plus Y
Yes.
is equal to 1 over 3. Then from here, actually this will give it. So from here, just simplify. This time that 3y is equal to 20 plus y. So which is 2y is equal to 20, which is y is equal to 10. Does it help?
Yes.
So what you have here is equal to 10 here. We could have said the same thing. Look, this and that is equal to what?
20.
20 is equal to 2a, then divide by 2 both sides.
Okay.
A is equal to 10. It was 1 times a, so it's going to be 10. A1?
Yes.
And if you want the entire thing is 10 times things, so which is this thing is equal to 30 units. So these are to help you when you're in trouble. If you don't know how to set up these kind of ratios.
Okay.
So if it's difficult to set up these kind of ratios, this is your plan B. What else? We're left with Z. Z, we're left with this one, right? So how do we go about it? We can say in triangle what? In triangle RST, right?
Yes.
And triangle RUQ. Because this triangle and this triangle, proportionality theorem. So we say, okay, in triangle, what? RST. RST. And triangle RUQ. It could also be RVP if you want. Because as long as all these are parallel to that one.
Okay.
Triangle RUQ. Triangle RUQ. What do you have? You say, okay, now. Say your, what you want? We want this side over here, right?
Yes.
So in that case, we'll say RS maybe over the entire side is equal to RT over the entire side.
Okay.
Are you following?
Yes.
You can also say what is this? RQ over R, this is equal to RS over that.
Okay.
As long as you take the direction of the same parts. So in that case, we'll say RS over, let's say UR. Let's just take that part over. RS over UR. UR is equal to, said RS over UR is going to RT over QR. RT over QR. This is the proportionality theorem. Why? Because your QU is parallel to ST. Is it clear?
Yes.
Because this triangle RST and triangle RUQ, which is your RS over your R is equal to your RT over QR. So in that case, your RS is equal to what? 10 over UR. What is your UR? Is 15 equal to RT. What is your RT? RT is what you're trying to find is Z over QR, which is 18. So which means 180 is equal to 15 Z. Then divide by 15, divide by 15. Get that your Z is equal to, what is 180 divided by 15?
180. And it's 12.
It's 12. So get that your Z is equal to 12 units. That's how to handle it. Is it difficult?
No.
No, as long as you understood those ratios from the proof,
Yes.
you'd be fine. Just know how to look at it. This triangle RST, and then you continue in that direction, RUQ. You could have said RST and triangle RVP. It's going to still work because as long as this and that are parallel, it's still the same proportionality theorem. And I'm done with proportionality, and I hope it does make sense to you too, as it does to us here. And thank you for watching. Cheers.